Hi there students. This video record is about uh, single component and assembly. What is the difference between an assembly and a component? After delivering a few sentences about such definitions and in doing this giving some examples, then I'm going to focus the attention to the other important definition, engineering drawing. While we have a classification, we group the engineering drawings into two categories. One category we say detailed drawings, the other category assembly drawings. Okay, then well, start and explain what I mean or what is subjected in this video record. First, I want to clearly explain what is the difference between assembly and single component. Okay. Yes, you're seeing the things from my computer. This is an object in general. This is another object. Well, in this example, the object is in chemical engineering an interesting object, unit. Well, it is just the system in which we have some pressurized vessels, 1, 2, 3 identical vessels. Within these vessels, well, we have a certain chemical reactions to realize. Okay. Well, to be able to support this heavy vessels, this platform is needed. Okay, you see the platform is supported by its legs, and to be able to allow the technicians or engineers to have a look at whether the reaction is okay, opening this manhole for instance, or looking at from this little window to see the inside. Well, there is a stairs, okay, to rise up, step up from the ground to the platform. And this system is say not very but moderate level, a complex system. It is controlled numerically, electronical system we have. Well, there is in the system such a unit. Okay, well, within this black box can see some microprocessors, electronical circuitry, and well, as the actuators we have electronically closed, open or adjusted valves, solenoid valves. Okay, this is what an object which consists of more than one components. Well, lots of components we have in this, even in this small system. The deck of the platform, stairs. This unit, this part is a sub-assembly. This vessel is a sub-assembly. But say in the example, all of those things, just in general speaking, can say that it is an object. And since it consists of more than one component, in general it is called an assembly. Okay, well, the software you see from this logo and the name of the software, it is written at the middle part of quick access menu bar, Inventor environment, Autodesk Inventor. It is an assembly. Okay, after having the model of an assembly in Inventor, whenever it is needed, we can isolate a sub-assembly. We can isolate a component of a sub-assembly. It is possible. Well, how the model of an assembly is created? It is an important question to deal in the content of the second course, computer-aided engineering drawing course. It is called in Middle East Technical Northern Cyprus campus is MECH 114. It is a mass course for mechanical engineering students. It had to be also for aerospace engineering students. The other students, for the other engineering students, MECH 114 is an optional course. It may be selected as an elective course. Okay, then, well, I said that if the solid model of an assembly is available, then whenever it is needed, well, the sub-assemblies and thereafter the components can be isolated. In the end, the isolated component finds its place in part environment. This is an assembly template, assembly environment. Okay, well, to demonstrate how it is done, actually, although these are just contented in MECH 114, just have an idea. Bring the cursor onto this sub-assembly, okay, and then right-click the mouse. Well, this menu appears in the screen in the vicinity of the cursor. If a click is done on Edit option, then, well, only the indicated one will be active in the domain. The other ones will be just in such a light tone, like a ghost, inactive. Okay, it is a good or advantageous thing to have the selected component in without leaving the assembly environment, of course, as active component or active sub-assembly. Well, this is not a component, this is a sub-assembly. It consists of different components, so it is an assembly. If there is a thing to edit, well, after having the selected part in edit mode, then you can deal with the rest. In MECH 114, you can see some examples. But if your purpose is just to isolate it from the environment and just to have the sub-assembly in another volume, then, well, after starting editing process, click on return button. This is to turn back to the previous stage, well, the assembly environment, where we have in this example the main assembly. To be able to isolate a sub-assembly from the rest and finding the sub-assembly in another assembly template, after indicating and right-click the mouse, select not edit but open option. Well, you see main assembly file is over here, but this is another file in which I have the sub-assembly, the model of the sub-assembly. Okay, one of the pressurized vessels. It is a sub-assembly. Okay, and then, well, continue. This is the cap of the vessel. Well, it is I think, yes, true, it is sub-assembly or a component. Well, check, select it and right click and then clicked on open tab. Yes, this is the component, one of the components. Well, at the top, well, the extension, the name of the file is written, and this file you see is a component, single part. It is not an assembly. Okay, this is a single part. This is what a sub-assembly. This is the main assembly. In this example, main assembly, sub-assembly, and one of the components of the assembly. Here it is the component of sub-assembly as well. Okay. Okay, then see one more example, and then, well, focus the attention to the definition. Detailed drawing versus assembly drawing. Another example, this is more interesting not for chemical engineering students, but for mechanical engineering students. It is a machine, it is the locomotive, okay, of a train. Well, it is an assembly, it consists of lots of components. Okay, then, well, you can select a part, sub-assembly, or a component, not to edit only, not to isolate it from the rest, but also to hide it. For instance, I want to see the inside of this part or that part. It is the main chassis, okay? Indicated with the left click, right click the mouse. Then in the menu, it will appear after right clicking. Do not select edit, do not select open, respectively. Edit button is to click to have the selected component as active, but the rest is as inactive. But if you select open option and click, then the selected one will be in a different file. If it is sub-assembly, assembly file. If it is a component, part file. But if your purpose is to take the visibility of the selected one from the screen, then, well, this select, bring the cursor onto visibility option, and then with a click, this selected. Then, well, that will, okay, it is still in the memory, but it is not in the screen. After taking that obstacle away, okay, via taking it as visibility, well, then see. For instance, I broke the cursor onto this part. It is, I know, a sub-assembly. Left click, right click, and okay, then say open. Yes, now you see I isolated a part of the assembly. It is also an assembly, it is a sub-assembly. Okay, and then, well, in this sub-assembly, you see we have an electrical motor to drive this mechanism. Mechanism is the main actuator. It amplifies the torque, okay, via decreasing the speed of rotation, can amplify the torque, and torque is used to drive the train. Okay, the wheels are rotated, and the created thrust force is used for moving the vehicle ahead along the railroad. Okay, then, well, this sub-assembly consists of some other sub-assemblies. One of them is this one, continue. Select and right click open. And then, yes, this sub-assembly, well, we have an axle and two tires, wheels. Okay, now I'm going to select this wheel and then right click, say open. Now this is not an assembly, this is a single part, this is a component. This sub-assembly consists of 1, 2, 3, and, well, we have bearing, I think, say this is a bearing here and another bearing there. 1, 2, 3, 4, 5 components, this sub-assembly. But this one consists of one component only, so it is a part, it is a component, not an assembly. Okay, and then I think it is clear enough what is assembly, what is a single component or component. Okay, in short. Then see, technical drawings. If the engineering drawing is to explain the shape of an assembly, main assembly or sub-assembly, but in general speaking, say that if it is such a sheet on which we have the views of an assembly, that sheet, after of course showing some dimensions, the necessary dimensions, and writing or putting some technical notes, necessary technical notes, and after filling the title block, filling in the title block, then as a whole, such a sheet is called assembly drawing. Assembly drawing in general is an engineering drawing, but in the classification, it is a type. Well, if the sheet is to explain the shape and provide the necessary size of an assembly, it is called assembly drawing. If the engineering drawing is to explain the shape and provide the size of a single part, a component, then in the definition we say detailed drawing. Okay, now after this introduction, well, can focus your attention to the slides of my presentation. Close these files. Okay, well, do not have CPU and RAM of the computer as very busy. Okay, without saving, close and close this file, and then the presentation. Yes, see the definitions and extend the vocabulary. Okay, technical vocabulary. Working drawing, or in general say engineering drawing. Okay, working drawing is a set of drawing used during the work of making a product for production. Okay, if it is a working drawing, then looking at the working drawing, then the technician, operator, or whoever is can find the necessary info about the object, to its shape, to its size, and some properties or characteristics. Well, working drawing or engineering drawing, well, classify engineering drawings into two groups. Detailed drawing, well, from the given example, you know that detailed drawing means it is the drawing to explain the shape and to provide the size of a component. Okay. The other one is assembly drawing. If the object to explain to its shape and to provide the necessary dimensions is an assembly, then such a drawing is called engineering drawing is called assembly drawing. Okay. Detailed drawing is a multi-view representation. But if the object to explain, the component is to explain is a simple right prism, it has only one thickness and it is right prism, so only one view is enough. One view is enough to explain its shape. But if the object is not a simple right prism but a composite prism, then well, need to use not only one view but 2, 3, 4, the limit is 6. Okay, those to show the object, the projection of the object, well, on a picture plane, the principal side of the object is parallel to the picture plane. You know, for any object we can define 6 principal sides. These are front, back, left, right, top and bottom sides. If the object is a complex one in shape, okay, well, can maximum have 6 principal views, multi-view representation. Okay. Well, to the end of the school, you're going to see the other type of drawings, not orthographic principal views, but auxiliary views. Okay. Some cases need to add some other views. These are called auxiliary views. I'm going to make the sentence clear enough later. But here say detailed drawing is in general a multi-view drawing. Well, this is important. By the way, why not take a pointer, laser pointer? Well, this is important. single part. If the object is a component, not an assembly, a single part, then yes, in speaking, say detailed drawing. Okay? Yes, detailed drawing. Of course, on a detailed drawing, we show the necessary dimensions and write the or have the necessary technical notes. Okay. If on the sheet, on the page, have the necessary views, dimensions, technical drawings, and what else? Fully filled in title block, then such a page is called detailed drawing. Okay. Other hand, assembly drawing is a drawing, yes, engineering drawing, of various parts of a machine or structure assembled in their relative working positions. Object, in other words, is the one it consists of more than one components. In general speaking, it is called assembly. If the drawing is to inform the reader on the shape and, well, the necessary dimensions of such a montage, then it is called assembly drawing. Okay. What is our purpose? Why we provide or use detailed drawings? You know, detailed drawing, using detailed drawings, engineering drawings in general, is one of the description methods today. Still, that method is used in industry. The other method actually can say that the best description method today is solid modeling. Okay, not use engineering drawings only, okay, but have solid model. Actually, if solid model is created first, then views can be created in the technology of today, okay, thanks to the existence of new generation software. It is really an easy cake, can create the engineering drawings in few minutes, okay, even seconds. Okay, well, detailed drawing conveys the information and instructions for manufacturing the part. Technicians looking at detailed drawings can achieve reading. Reading means looking at the views, bringing the 3D shape of the object into the mind. Okay, and also seeing the given dimensions, the dimensions shown on the page, they can be informed on the size. And reading the technical notes can learn some things on the characteristic or properties of the object, or if it is for not the object but it is surface, then surface characteristic can be learned reading the annotations and or some technical notes. Assembly drawing conveys the completed shape of the product. Okay, while looking at the page, reader can see that it is not a single component, it is an assembly. For instance, looking at the drawing, then reader can understand that it is the view of an assembly. For instance, here, well, in the example which I gave it just at the introduction part, one more time open it. Well, this is the locomotive, an assembly, and well, engineering drawings. Well, after isolating the component, for instance, this one, okay, yes, well, here it is a sub-assembly. There is a damper and a shock absorber spring. Isolate this one. Okay, well, this one, now I'm highlighting it, is a single component. If for a component, then well, create the views, then it is going to be as a whole detailed drawing. But if you create the view for an assembly, let's quickly demonstrate. I selected well, unit system, and also for view creation, making such a selection means also the quadrant is selected. When selecting metric unit system, I selected the first quadrant. And then bring the cursor onto the template option. If the software is Inventor, not AutoCAD but Inventor, then unless otherwise requested, well, create the views using the template of Inventor. Have the file in Inventor format. But the preceding template icon, just from its extension, can see that it is to have the things in AutoCAD format. Inventor is a compatible software, although it is Inventor. Well, selecting this template can create the file in AutoCAD format. But it is to be mentioned by the teacher in school or in real life by the other person. He or she will use the drawing well, to deal with the manufacturing issue. Unless otherwise mentioned, don't make the selection on this template option. Okay. Select ISO IDW. It is for for having a paper simulation. Okay, and then, well, since the object is a big object, I'm going to use a bigger paper in shape, edit sheet, not A3 size, but select A0 size. Okay, and start the view creation process, and then teach to the software which side is front side. Well, I'm going to define this side of the train as it is front side. Okay, scale factor you see at present 1 to 50. Well, 1 to 20. I think more proper. Okay, scale is 1 to 20. Write it if you want. Well, 1 to 20. Okay. Well, if it is an orthographic view, then, well, the normally created orthographic view, not sectional view, then the first style button must be on, not the others. And then move the cursor in this direction, make a click. This is to say that top side view gonna be over here. Move the cursor in this direction, make a click. This is to locate the left side view of the train. That is it. And then clicked on OK button. Yes, at the background now, well, the software running view creation subprogram, and then yes, the images of all the things. Okay, this is an assembly. This is going to be an assembly drawing after showing the dimensions and well, having the title block and the complementary table. Well, I'm going to briefly inform you on such things, saying complementary table, what I mean. Well, okay. Now, one more time, close this solid model and the last created drawing file. Okay, and then turn back to the presentation. Yes, assembly drawing conveys a completed shape of the product, overall dimensions. Yes, this is important. If the drawing is an assembly drawing, okay, show not the dimensions of all the features, but the overall dimensions. What else? And location dimensions. For instance, in the assembly, where is the electrical motor? Where is the chassis? Well, relative to some references or the same reference, using location dimensions, mathematically speaking coordinates, well, can inform the reader saying reader in general, well, I say reader, Depending on the case, reader may be a technician, may be an associate engineer, may be an engineer, may be designer. Okay. Well, show the relative dimensions, overall dimensions and relative dimensions, location dimensions. But in detail drawing, well, it shows the images of a single component. We show not overall dimension. Saying overall dimension, we mean width, yes, width, height, and depth. Overall dimensions. In Turkish, genişlik, yükseklik, derinlik. Well, at this point, open a parenthesis and then saying width, height, depth, we mean what? One more time, see. Well, one more time example, or just select this example. You know, this week, second week, started to study on this example. Well, after defining the front side of the object, later I'm going to inform you what is the measure, what is the criteria to use, okay, in selecting the side as the front side of the body. Answer this question later. But say that, well, obeying to the, using the criteria or satisfying or obeying to the rules, you selected this side of the object as it is front side. Then after saying that it is the front side, of course, this is relative to the observer. Assume that you are observing the body in this direction. Yes. And your rays of sight are toward that side of the body. And, well, this observation for outputting the front side view of the object. Yes, this is the front side. After saying that it is the front side, then you know the opposite side of the object here, it is this side, is called back side. Okay. And if this is the front side, then, well, relative to the observer, this side of the object is at the right hand side. So, well, right hand of the observer, and it is just the same side. At the side, observer keeps his or her right hand, and this side surface is at the same side. So it is called right side of the object. And, well, since this is the outmost surface, most out surface, it is called rightmost surface. The opposite side is the left side of the body, and that's its surface, left side surface. Front, left, back, right. How about top? Well, in this example, relative to the surface of the earth, well, which side is more away at a higher level relative to the surface of the earth, or it is at the highest level, then it is called top side. Well, here, for the main part, this surface is a top side surface. Okay, this is the top side surface of the cylinder. But since this cylinder is not a component but a feature, then can say that this annular flat surface is, in this example, of course, is also the top side surface of the object. But to be able to explain, you're talking about this or the other top side surface, mention, say that top side surface of the base, top side surface of the cylindrical feature, or since this is at the highest level, can say that most top surface. Okay. And the opposite side is the bottom side. This is the bottom side surface. This is the bottom side surface. This is a bottom side surface. But most bottom surface is this and that. These are at the same level. Okay, and then after reminding you on such basic definitions, well, front, top, left, right, back, Then see, saying width, we mean what? Width is the, if someone simply says that width, this means width of the object. Okay. But if the width is the size of a feature, then it should be mentioned. For instance, say that width of this triangular prismatic feature, width of this cylindrical feature, width of this channel. Okay? But in here, say that width, then it is considered as the width of the object. Width of the object in our example, well, sir, first, in general, say that width of an object means the shortest distance between the most left surface and the most right surface of the object. It is called width. Here, well, learn the width of this object. Inspection tool, measurement tool, and then distance between this surface, which is the most right surface, and the most right surface. Yes, inventor measurement tool saying that 200 millimeters. Since I said that this is the front side, then 200 is the width, by definition, the width of the object. Well, the height of the object, distance between the most top surface, in this example is that, and bottommost surface. Yes, here the result, measurement 140. In this example, 140 is the height of the object. Okay? Yes. But here, distance from here to there, this surface is the height of the cylindrical feature. Okay. How about depth? Depth is the distance which is between the most front surface and the most back surface. In this example, the depth of the object, distance between the front and the back side. If it is, of course, for the object, entire of the object, that is the width, say that is the depth value, 100 in the example. Okay, I think this became clear enough. Width, height, depth. And then one more time, focus the attention to here. Yes, on an assembly drawing, overall dimensions, I said that width, height, depth, these are overall dimensions, and relative dimensions, location dimensions, to inform the reader on the location of the components with respect to a certain reference. And of course, reader looking at an assembly drawing can see the relationships between the components, among the components. Where is the wheel, where is the tire, where is the platform? Okay. In a detailed drawing, yes, we have in the format, by the way, I have already talked about drawing paper format, working area, margin lines, and title block, and sufficiently talk about the content of title block. Here, we'll say that on a detailed drawing sheet, what we have title block to provide general information. What is the name of the responsible company? Who is the designer? Who is the technician, drafter? Who is the associate engineer? What is the drawing scale? What is the geometrical tolerance class? What is the size tolerance class? The object is to be made of which kind of material? Okay, and name of the object. Yes, these are all to be in the content of title block. Yes, and part information, the information on the part. What? Shape info, size info. For shape description, we use in engineering drawing projection technique. For size description, dimension format. And of course, via writing some technical notes, most of the cases along the shoulder of leader lines, such as whole representation notes, specification notes, okay, will provide some complementary info. In the content of title block, yes, name of company, name of the designer, etc., etc. These are all to be written. As I said, if the project is an international project, or if design office does not know that project going to be used in the application in which country, then normally English is to be used as the language in filling the blanks of title block. But if design office sures that that drawing going to be processed at the field in Saudi Arabia, in Syria, Iraq, Arab countries, then write the things in Arabic. If it is gonna be the market, industrial application part in Turkey, then write the text in Turkish. Okay. Shape description, yes, we use orthographic projection. Pictorial drawing is out. Beforehand, there was no solid model software. Okay, so yes, it was quite common to be able to inform the reader on the shape of an object in case reader is not a technical person, he or she is a lay person. Then instead of using orthographic projections, we use pictorial drawings. It shows the object as it is photographed. Okay, instead of drawing, for instance, for a rectangular prism, it is orthographic front view, orthographic top view. Yes, in pictorial drawing, using, for instance, isometric drawing technique, although you see this slide is two-dimensional domain, you see using isometric drawing technique, just saying that it is a rectangular prism. To be able to understand what it is, education is needed, but while this figure, it shows the object like as if it is photographed. In general speaking, we say pictorial drawing can be read by any person. Well, today, instead of using pictorial drawings, we create solid models, So pictorial drawing today can be taken from the content of engineering drawing courses. This drawing technique is now, say, out of. It is off, okay? Not on, not in, it is out. Okay, size, yes, we use dimension lines, dimensioning format, and if you watch the previous video records, one of the previous video records, then you see, of course, while talking about the content of title block, briefly make an introduction, saying that even in today's technology, impossible to set the size of a feature exactly as equal to a certain specific number. For each feature, for the size of each feature, there should be an allowance. We should use upper and lower limits, okay? And if the operators, via shaping the stock and setting, via which setting the shape of the object, shape of the feature, if it is size, can find this value in the range bounded by upper and lower limits, then can say that size of the object is sufficiently correct. Tolerance means the difference between upper limit and lower limit. For each dimension, yes, there is a tolerance. After the midterm exam, one of the class time, I'm going to talk about tolerance, all the necessary things at the level of course, in detail. Yes, at the title block, if it is an assembly drawing, well, part number is important. I'm going to talk about part number, what is that, in few minutes. Okay. Yes, the material of the object is written where at the title block into one of the pigeon boxes, and some general notes. Okay, about surface quality, about the treatment process, and general tolerance note is written at the title block. Okay, and here there is an example, this presentation, not locomotive, not chemical reaction unit, but this sub-assembly. It consists of, well, how many components? It is not a main assembly, it is a sub-assembly. Well, at this site, imagine that there is a motor engine, or just say not M but E. Saying E, I mean engine. There is an engine at that site, imagine. If you imagine the preceding and following part of this object, then can say that it is the main assembly. Okay, engine. At this site, well, one component of this part is in contact with this gray colored machine element, is the machine. The rest of the machine. There is a mechanism over here. Okay, and this sub-assembly is to transmit the motion from engine to the rest of the mechanism, rest of the machine. Of course, well, while the motion is transmitted, well, the energy will be as embedded, will also be transferred. Okay, well, this part of the main assembly, what we have, this gray colored one is a gear. This is a gear. In Turkish we say dişli çark. In MECH 114, well, it is the title of one of the chapters, and sufficient to talk about what is gear, what is the thing to know for creating the model of a gear. How about it is, say, technical drawings, specification notes, etc. All of those things are in the content of the second course. Okay, the green colored one is another component. You see, these are components. It is called shaft. This green colored one is a very common machine element, shaft. Shaft is rotated. Okay, there is an input, there is an output. Okay, input applies the necessary force, rotational effect is created. Well, it is applied, torque we say in the jargon. Okay, the moment of the forces, okay, with respect to the axis of rotation for a rotating body is called torque. Okay, at the other hand, the green object is under the action of the rest of this mechanism. So if a cylinder to its main shape is under the action of the oppositely directed rotational effects, torques, at one side engine, the other side the mechanism, then such a rotating body is called shaft. Okay, shaft is a transmitter. It is for transmitting power from the engine to the rest of the mechanism. It is rotated. It is type of motion is rotary. Well, shaft together with the gear, of course, are to be supported, because at least under the gravity force, the attraction force exerted by the earth, otherwise if there were no such a support, then this part of the assembly will drop. Well, this violet colored one is a support bracket. Support has been assembled using this joint. It is a welded joint to this part of the assembly. Say that it is the chassis. Of course, here it is in simplified form, chassis. Okay, this is a support. And well, shaft is to be allowed to rotate about its axis freely. To be able to decrease the effect of friction while the shaft is rotating within the house of the support, well, between the house, the hole of the support and the shaft, try to see, it is partially seen in this model. We have a special machine element. It is a bearing. It is called in general bearing. In this example, it is a rolling type bearing. In Turkish we say yatak. Well, this gear is to be connected to the shaft. How? Using rectangular prismatic elements. This machine element, and well, at the symmetry side we have another fastener. This special fasteners, these are used to fasten a gear to shaft or vice versa, or pulley a shaft vice versa. Is called key. This is a key, this is another key. In this assembly there are two keys. Well, whenever the shaft and the connected other components going to be under the action of axially directed force or forces, then to be able to prevent displacement in the axial direction, we use such rings. This eggplant color ring is in general, to its function, is called retaining ring. It is to retain, prevent the shaft, okay, from moving in the axial direction. Retaining. Yeah, just I'm using my mouse to write such a text. Okay. Well, it takes a certain time. Retaining ring. Okay. Yes, well, very small to its number of components, sub-assembly. Okay. And then, in the classification we have assembly drawing, detailed drawings. Well, in this example, it is a sub-assembly, so well, as the drawing sheet, there will be only one assembly drawing. But if the object were a main assembly, then, well, for the main assembly, one assembly drawing. For each sub-assemblies, correspondingly, assembly drawing sheets would be necessary to use. But here in our example, you see this word is singular because we have only one sub-assembly, so it is technical drawing, can be fit to its views. Of course, views can be fit over a single sheet, so it is singular. But for each non-standard components, an engineering drawing is needed. Well, after saying non-standard component, then okay, return back to here and then see which components are non-standard. Well, standard component means, well, at least one of the standardization association has already published a document, and in the document all the characteristics, all the properties in shape, in size, and even in the technology manufacturing method are all written, are all explained, subjected in such a document. Then if it is the case, there is such a document, then the object is called a standard object. For standard objects, no need to use or ask or create or draw detailed drawings, because, well, in the libraries, thanks to the publication of the standardization associations, we have the documents for standard objects, and someone can gather full info about a standard component. But if the component is a non-standard one, this means there is no such a document for that object, then yes, detailed drawing is needed to be able to inform the reader on the shape and size of the object. In this example, gear is not a standard object, shaft is not standard object, support is not standard, chassis is not standard. So, well, in this example, there should be one assembly drawing, 1, 2, 3, 4 detailed drawings. These are respectively to explain, to provide the necessary things for gear, for shaft, for chassis, for the bracket support. Retaining ring is a standard component. Bearing standard, keys are standard. So for standard components, there shouldn't be no need to have or provide detailed drawings. Okay. It's already talked about such things. And then this part is also explained. And then in the given example, yes, this slide, what we have the assembly drawing. Actually, since this is a lecture note at the top, well, there is such a note. Actually, in industry, every technical person should know that it is an assembly drawing. So no need to write such a note, because if the reader is a technical person, he or she must know that it is an assembly drawing. But since this is my lecture note, that's why it is written assembly drawing. How you can understand? I said that every technical person can understand that it is an assembly drawing. How? What is the measure? Once having a look at how you can say directly something that it is assembly drawing, it is not a detailed drawing. Well, there are two strong indications. These are just saying that drawing is an assembly drawing. One of them is just, you see the similarity. There is a line, it is a leader line with arrow. It indicates this component, and at the end of the line, indication line, there is a circle, and within the circle there is a number. To its appearance, it looks like balloon. Okay, flying balloon. Yes, in the jargon, because of that similarity, we say balloons. If on the page there are balloons, okay, then no doubt it is an assembly drawing. Okay, the balloons just are to indicate the component on the view and inform the reader on its ID number. Yes, we identify the components of an assembly using numbers. Well, first component, and you see this is the second, third, and so on. Why this has been identified as the first, that one as the second? Well, the answer of the question depends on the policy in the company. If company considers the cost of manufacturing of the components, then yes, well, which component is the most expensive component, the cost of which component is the highest, then say that it is number one. Okay, it is one of the measures. Some companies use this measure. Which one is in the highest cost, then say it is the one. And say the cost of this is less than the other, so say it is 2, and so on. But some other companies use not the cost but the volume. Well, the volume of which component is highest, the greatest object in size, then it is called number one. Okay. Well, reader looking at the balloons can see their identifications, ID numbers. Okay. Yes. And well, here in this example, this part of the sheet now I am highlighting is the title block. where we write the name of company, name of object, etc. But you see we have another part here. It is like a table. Yes, it is called parts list. And such a title is written to draw the attention of the reader that it is an assembly drawing and that is the part list. Yes, the existence of part list is the second strong indication, okay, to directly say that it is an assembly drawing. Okay, on a detailed drawing we never have such a table because it is for a single component and title block is sufficient to provide the info. But for an assembly, yes, see, in the table, in this example, the table is in minimum content. There might be some other columns. Well, along the first column, we write the ID numbers of the components. Along the second column, we write the names of the components. So, well, for instance, after having a look at and seeing that it is component 1, then if you wonder what it is, then okay, refer to parts list and component 1, that is the name of the component. This means it is a shaft. Component 2, it is bracket base, chassis. Component 3, bracket, support. Okay, spur gear, component 7. Here it is the leader line, it indicates this component. It is a gear, spur gear. Okay, so on and so forth. And there is one more column along which we write the number of components, identical components. In our example, there is only one shaft, so number of shafts is 1. But in the design of this, in the structure of our assembly, there are 2 keys, 2 fasteners. Yes, it is written along this column. There is one more column, it is a mast. Well, drawing number column. Actually, each sheet in the archive, in the folder, okay, project folder, is identified. It is like a page number, okay, in a project, especially if the assembly is a complex one. For instance, main assembly is an aircraft. Even in the order of few thousands, few hundred thousands components can be found. So, well, if it is the project folder, and at the appendix of the folder can find one more folder in which can find the printed copies of technical drawings. It is gonna be like a thick book with lots of pages. If you identify the pages, it is in the jargon called drawing number, just in the similarity like a page number. Then in case it can be, the page can be, engineering drawing can be much more easily found in the folder. For instance, someone may say that, okay, sheet number 10, open it and then do this, do that. So drawing number is written along this column if there is a drawing sheet, of course. As I said, for non-standard parts, there must be a drawing sheet. It is for each component, yes, there must be non-standard component, there must be a technical drawing, detailed drawing. So physically, after printing, detailed drawing sheet. Identify that sheet, okay? But for standard components, since there is no need to use engineering drawings, because in the library someone can find the document published by Standardization Association, this column will be empty. Do not fill in the column because there is no drawing sheet. For instance, for parallel key, well, there will be nothing in this box. But for spur gear, okay, whatever the drawing number for the sheet, it shows the images of the spur gear, then it must be written over here. Retaining ring is a standard component, so Well, there will be no technical drawing for retaining ring, so no number to write. Washer is a standard component, no need. Bearing is a standard component, but bracket non-standard. Into this box, write the drawing number, sheet number, where on which the bracket is described to its shape and to its size. Bracket base non-standard. Shaft non-standard. Fill in these blanks. How the drawing number, sheet number is generated? I'm going to answer this question in few minutes. The nodes column is extremely valuable for standard components. Okay, there is a parallel key, but which kind of parallel key? Okay, or what is the code of the document? Document number. It is also called standard to find, to refer in the library. The code is written along the nodes column. Here, in this example, DIN is to say that the parallel key is to be the one in accordance with Germany definition, Deutsche Industrie Norm, and 6885 is the number of the document. Okay, it is like a code. And then the rest for some technical notes after the code of the standard, after the ID number of the document. If we have some others, then most of the cases these are just in brief the main dimensions of such a standard object. For instance, it is 8 by 7 by 18. 8 by 7, just the size values at the cross section. 18 is the length of that machine element. Okay. I can say similar things for the other technical nodes. These are for informing the reader which kind of washer, which kind of retaining ring, which kind of standard machine element are to be used in the structure of such an assembly. For the non-standard parts, no need to write a technical note, so this part for bracket is to be empty, bracket base empty, for the shaft empty. Okay. If it is a weldment, if the components, at least two of them, have been connected to each other applying welding process, yes, it is the place, it is the technical drawing to show the necessary annotations. If you take MECH 114, you can learn the meaning of this annotation. It is to say that, well, bracket base is to be connected to the chassis applying fillet welding process via fillet weld joints. Okay, joint size, throat length is 5. Okay, well, welding symbol, in general we say welding symbol. Okay, this is a welding symbol. We show the welding symbols on an assembly drawing. Welding symbol. Okay, note up, this is an assembly drawing. How about the dimensions? Yes, I have already informed you. We show overall dimensions. 154, you see, is the distance from the most left surface and the most right surface. It is the width. This is the width of the assembly. Okay. 120 is the distance between the most front and most back sides of the object. So it is the depth. Here it is the depth, saying capital D, I mean depth of the object. And 142 is the distance, shortest distance between the most bottom and most top levels. It is 142. It is the height of this assembly. And location dimensions, yes, this dimension is a location dimension, coordinate. It is to say that relative to the right side surface of the chassis, this surface, well, the bracket is to be assembled 20 millimeters away. The location of the bracket surface of the bracket is over there. It uses this coordinate 20. Okay. Well, another feature 55 is a location dimension. But referring to an assembly drawing, you cannot find such a dimension. For instance, what is the thickness? What is the width of the gear? What is the diameter of the shaft? Well, to find the answer of such questions, these are about the dimensions of the features. The correct address is not assembly drawing. You cannot find such dimensions. You can only find the overall dimensions and location dimensions. You can get the assembly drawing. For finding such dimensions, then refer to the detailed drawings. Example for the shaft. Yes, this is a detailed drawing. Okay, in our example, it is the detailed drawing sheet for the shaft. Yes, at the title block, there is no part list, by the way. There is no balloon. Okay, this is the title block, name of the company, name of the object, tolerance node, quadrant symbol, and the name of designer, etc. Scale factor. Okay, fully filled. And here we have the views, necessary views, okay, and the dimensions. And technical notes, you see there is a technical note here, another technical note there, okay. Well, as a whole, such a sheet is called detailed drawing. Okay. Well, here, one more time, draw the attention to the difference between detailed drawing and detailed view. Well, here I highlighted it, I indicated. There is a zoomed projection here. It is to show the bounded part of the object. Well, on this view, well, here we have a retaining ring groove. And for the retaining ring groove, the selected scale factor for the main views, principal views, is not good. Is not a suitable scale factor for such a tiny feature. Relative to the size of the rest of the object, the size of this feature is very little. So under the suitable scale factor, yes, we can have the views of the main part of the object, and reader looking at the front view, top view, etc. can see what is the geometry. But looking at this part of the projection may not distinguish that there is a groove over there. In general speaking, whenever on the projection under the selected scale factor, the image of a certain feature won't be distinguishable, cannot be recognized because it is very little on the projection, then, well, it is like having a look at such a part using a microscope or magnifier. Well, in the format, bound the region with a circular fence, and then, well, in the vicinity of this region, say in the vicinity of the view, find an empty space and show the image of, if it is a creation, via creating, if it's a drafting, via drawing, the image of the part, it is bounded by this fence, only this part. Well, for instance, here scale factor is 1:1 for this projection, but for that one is 2:1. Okay, it has been 2 times greater, 2 times bigger in size. It has been drafted 2 times bigger. Well, since it is bigger in size, then, well, can see that over here there is a groove more easily. And for such a tiny part, the suitable view to show this dimension, not here, but there. On the detail view, show the dimensions. Such a zoom projection, where we have the image of the selected part of the object under a greater scale factor, is called detail view. But all of such things are called, say, that sheet on which we have all of such things is called detailed drawing. This is not drawing. This is called detail view. Okay. Well, you can find a video record. It is just to inform you what is the thing to do, okay, for creating a detail view in Inventor. Okay. I don't want to demonstrate how in this video record because it is available. You can find the record and then watch it. Okay. Yes, detail view, and then I think that is okay. Yes. Okay, well, I think it is clear enough. Well, drawing number, sheet number. How it is generated? I said that, well, for assembly drawing, it is going to be over a sheet. For detail drawing sheets, okay, we use page number. In generating the page number, but in the jargon, do not say page number, say drawing number. Well, it is the most common logic used by most of the companies. Explain what it is. For instance, this assembly is the product of a company. Okay, here in the example, the company is Otosan, a Turkish company. Okay, this product, since the foundation of the company, okay, in sequence, let's say is the 250th product. Okay, Otosan up to this time, let's say in the example, has already manufactured and marketed 149 different objects, and this is another object. And in sequence, it is the outputting number from the company is 250, 250th object. Okay, and then in generating the drawing number, it is the number to write into one of the boxes of the title block of the assembly drawing. Yes, put a dash and then write 0. If in the assembly the number of components less than 10, 10. Greater than 10 in number, less than 100, 2 zeros. If the assembly is the one, it consists of more than 100 components but less than 1000 components, then write one more 0, and so on. Okay, that is the drawing number for that assembly drawing, let's say. Write it into the box. Okay, here in this example, the drawing number for this sheet, since there are, you see, total 8 components, then the drawing number for this sheet is to be 250-0. Yes, this is the assembly drawing number for this sheet on which we have the images of the assembly. Write this number into one of the boxes, for instance this box of the title block. How about the numbers to write along this column? Sheet numbers for detailed drawings. Well, one of the sheet is the one on which we have the views of the shaft. Generate the number, drawing number. For instance, I selected this part of the title block and into this box write the number. Which number is to be written into this box? It is the sheet number, drawing number. 250, write the same number. It is the product number. In our example, I said 250. And then put a dash, and then have a look at the assembly drawing and see the ID number of the component. For the shaft, it is 1. Okay, then after the dash write 1. That is it. it is just having a look at the drawing number, can see that this means this is the sheet, okay, on which we have the views of the component, okay, in the structure of assembly. It is ID number, product number is 250, and that component is number 1, okay, the first component. If in the structure of the assembly there were more than 10 components but less than 100, then well, in generating the sheet number for this component, we will use such a preceding number. It is to be 0. Okay, then I think it is okay. You understood what I mean saying sheet number and how it is generated. Okay, my dear students, I'm going to finish this video record. Allow me to see who is the speaker. It is Associate Professor Dr. Murat Sönmez. It is me. Okay, Middle East Technical University, Northern Cyprus campus. Okay, bye bye. Stay healthy.